Okay, hey, this is the unit we've been waiting for. This is the final unit before certification. We're going to talk a little bit about control. Okay, we're going to talk a little bit about SPC. We've already talked about it. I've sent you the link to the asq.org. We can actually download an SPC chart interactive. This has been around since 1924. Walter Short up in Western Electric came up with this concept. And what it did is, before they just take snapshots and just do the stats on it, what a control chart does, it actually takes into consideration time. So you plot the variation over time, and then you can analyze it. Okay, and you're looking for what it does for us. It looks for special cause variation, and it's rule of thumb about 1 in 400 chance. And I'll pull that out, and you can figure. Actually, when you get a special cause, those are the easy ones to fix. It's the random variation that counts. And there are two types. There's one for variables, one for attributes. With computers, I'm just going to tell you, you can use a variable chart. Just take enough data, and you can do the variable chart. So you take these SPC charts, right? And from that, you'll pull out the average. You can get the standard deviation. And you can see if you're doing consistency of performance. And also, this is the basis for evolutionary operations. Are you getting better? Whatever that may be. Trouble with these things is you got to keep on top of them. People will stop doing it. We talked about this a little bit, about accountability. They won't do it unless you make them do it. All right? And this can be automated. Take those old computers out there and just make them do it. Bottom line. Okay, another thing is the rational. How do you subgroup these things? You want what's called rational subgrouping. So what you're going to do is you're going to pull out a 5-piece, 6-piece, whatever sample size. What that does then, it takes advantage of the central limit theorem. And no matter what the distribution looks like, you're always going to get a normal curve. If you're pretty sure it's a normal curve anyway, and there's no rhyme, no reason to it, one-piece flow, just individual moving range, that's the way to go. But just make sure you're not missing any opportunities to learn. That's what rational subgrouping is about. Okay, control plans. So you got all this work. How are you going to make sure it doesn't happen again? And there's different types. It's not a replacement for work instructions or standard operating procedures. This is what you put out there, either document or whatever, to make sure it doesn't slip back into an unpleasant state. You can do the prototype, pre-launch, production, and the control plans will actually evolve with the process. Okay, you want to put one person responsible. And again, we're going back to accountability. If this thing messes up, you can know who to nail. Say, hey, look, you're not doing your part. That's the whole point. Accountability again. And you give them a control plan. And this is the way, this is the rule. This is how you're going to do this. Okay. Okay, this is an example of a control plan. Very straightforward. Who's the process owner? Who developed the control plan? When was it developed? And it'll tell you the process number, the part number. And it'll tell you what the process name is, what machine is going on. It'll tell you the characteristic, also some kind of blueprint. It'll tell you the process. Is it critical to quality? It'll tell you what the specification is. It'll tell you how you're going to measurement, what kind of gauge. And it's going to tell you your sample size. And it's going to be the control control method, I'm sorry, and reaction if it does go under control. And this also, you see what it says P chart. This is a, back when before you had computers, this is the way you did it with a P chart. This is an attribute chart. I'm telling you, just use the asq.org control chart. But if you take the test, ASQ test, they still ask about the different control charts. But man, we got the ability, electronic gauging, electronic control charts. Just flood it with data. There's no reason to do it. If you get enough data, you can actually use a variable control chart to take care of attribute problems. If you have any questions, go ahead and zap me an email. And with that, I think we're done with Six Sigma Greenbelt. Nice job. This is not an easy course, and I hope you can apply it. You have my email. Zap me questions if you have it after you start using it. It doesn't end here. Nice job. Thanks.